Uh, Good morning, gentlemen. I will present the project, which the name is Automatic Smart Grid Restoration. I will go through the details of this project charter, and then whatever questions you have, I'm available to answer your questions.
Okay. Thank you.
So the project name is Automatic Smart Grid Restoration. And the purpose for the project is this Automatic Smart Grid Restoration, or ASGR. This is a system and it shall be incorporated to support and relieve the control room operators during the disturbance situation, especially during bad weathers. And what it will do, it will utilize the automation devices in the field. It will take the data from those devices, and it will normalize the network based on the alarms. So this is a real-time closed loop function that automatically isolates the faulty network components and reconfigures the network after verifying the more reasonable alternative to restore services without any human intervention. According to our KPI for the entire organization, the objective of this project is to reduce the supply restoration time to 2 minutes for feeder with fully automated devices. And at the end of the projects, we will have a centralized self-healing application installed at the existing SCADA system. So,
Mohammed,
yeah.
One question with this: is this like a hardware device that will be installed, or is it something in the control room?
Yes, it will be. There is no hardware. Hardware already installed in the control room as a SCADA system. So this will be an application which will be installed in the existing system. This application will analyze the alarms received during the disturbance situation, and it will restore the supply without any human intervention. Like the current process is, there is a control room engineer. He's looking for the alarms, and based on the alarms, he is restoring the supply. He's taking that decision, right?
Okay.
But now we already have fully automated feeders. We can control them. So why not have an application that can take the role of a control room engineer and decide how to restore the supply?
Mohammed, I thought
yes.
that DMS was doing that.
Yes, we have a DMS for that one, but for the DMS system, it is just a supporting function for the control room operator, but this function will work as independent. The DMS system, it has a limited capability because if there are more than 2 or 4 or 5 disturbances, it can only advise the operator. The operator will be busy analyzing some outages, but meanwhile, if another outage come, he cannot do it. Okay. Whereas automatic smart grid restoration, this application is independent. It can handle up to 100 outages at the same time.
Oh, wow.
Yeah. So our main milestones are the successful testing of this application at the testing system by SCADA team. The next milestone, we will do user acceptance testing. And the third one, we will do a real-time testing for this application. The indicative budget is $100,000 US. And our senior manager, distribution control center, will be the project manager. And this project is already approved by the vice president for the network operations.
Okay. And what sort of time frame are they looking at for implementing this?
Yeah, it's a 1-year project starting from today.
Oh, okay.
Yeah, I will just tell you some of the operational rules for this application in the 33 or 66 kV network. So there are 3 simple rules. Number 1, the area of operation for ASGR based self-healing shall be restricted to 33 kV radial circuits only. We will not utilize this application on the ring configurations. This will be used only on the radial configuration of the circuit. The second rule, ASGR will be blocked for all the trips out of the 33 kV circuits. For example, if there is any bus bar trip or transformer trip, this application will not work. This will work only for the overhead line circuits and cables only. Third rule is ASGR will be blocked in case of multiple 33 kV circuit trips in the same 33 kV ring. I will give you an example for this rule. Say, if you consider 4 substation, the name is SATW, DPC, JRT1, and industries. All of them are connected to each other through overhead line circuits. A, B, C, D, and E, all of them representing the circuit breakers. The filled means the circuit breaker is closed, whereas unfilled means the circuit breaker is open. So I can say that INDS substation feeding JRT1 and DPC, whereas the other line is fed from SATW substation.
Yep.
So in case of multiple circuit trips, like a circuit from JRT1 and DPC trip, at the same time, INDS and JRT1 also trips, so ASGR will not work for multiple 33 kV circuit tripping.
So that'll take just the initial trip.
Yes, it will. Initially, our aim is to handle only the simplest trippings. In case of any complex overhead line trippings, operator will intervene.
Okay.
That's a one-shot thing.
Yes, this is only one short thing. Like, for example, if there is any tripping between the circuit of JRT1 and DPC, then the CBC and D will trip on protection, and the one substation DPC, it will be affected. So in this case, what ASGR will do, ASGR will confirm that the substation is already isolated, then it will close the circuit breaker E to restore the supply of DPC substations from SATW.
Yeah.
Okay.
Right. In case 2, if there is a fault between the circuit of JRT1 and DPC, and only one circuit trip from the feeding end, which is C. So in this case, first ASGR will isolate the faulty circuit by opening circuit breaker D.
Yeah.
Once it is confirmed that the fault is isolated, then supply will be restored from SATW substation. In case 3, if circuit trip from C and there is, if circuit breaker open from CBA, so it means there will be interruption of 2 substation, which is JRT1 and DPC. So in this case, there will be no restoration of the supply because there are more than one circuit de-energized, which is between INDS and JRT1 and JRT1 and DPC. So it is very difficult to find out where is the fault, and operator will manually first check the location of the fault. He will check the distance of the fault, and then he will take the decision. So ASGR in this case will not take any decision.
Okay.
Right. Now we have a project governance plan for this one in line with the company's objective to reduce the customers of supply to 2 minutes. This project is in line with the company's vision of 2020. And the governance plan is detailed according to the scope. We will not allow any scope creep, and no gold plating shall be allowed, which cause change of more than 5,000 increase in the cost. So that will be referred back to the Vice President for their approval of the budget. The timeline for this project is 1 year. And any deviation for more than 2 days shall be immediately communicated to all the stakeholders, and along with the regular bi-weekly report. For the cost, it's $100,000 budgeted cost. So any increase in cost by more than $1,000, it shall be reported to stakeholders. The resources shall be hired as per company policy. For the communication, we will send a bi-weekly report. The risk, in case of occurrence of high and medium risk, it shall be immediately communicated to stakeholders, and whereas low-level risk occurrence shall be communicated in the bi-weekly report. The stakeholder engagement, we already identified the core stakeholders, but we are open. So if there is any new stakeholders identified, we will communicate to everyone. All the documents are available on the portal as per the knowledge management plan. And if there is any conflict management among the stakeholder, it shall be communicated to the resolution committee. And the decision-making framework is the change control board shall be communicated to director projects and programs. The scope and WBS for the projects, The project will start on 1st January 2018, and the expected date of completion is 31st December 2020. And we have already included the inclusions and exclusions and assumptions for this project. And there are some constraints and key risks already there, which we will discuss in the core meeting of the stakeholders.
Just one question.
Yeah.
Those dates, they're back about 4 years.
Yes, because the project was, we are considering it's an old project. So I'm just giving you presentation. Yeah.
Yeah. Okay.
And this is a RSC Matrix. I will share this RSC Matrix with all the stakeholders. So if you have any comment on it, so I will be available to discuss in the next upcoming meeting. Yeah. And also the project risk and their mitigation plan, we will discuss in detail in our risk management meetings. So this is a kickoff meeting, and we are going to organize a detailed meeting to discuss all these plans. And do you have any questions? You can ask me.
That was pretty good.
So this is replaces DMS. Is that what you're saying?
Yes, this will replace the DMS because this is more intelligent than the DMS system.
So you're saying it can handle 100 and so faults down the line,
Yes.
but it's only one-shot operation.
Right.
So if there's a problem down the line, it opens up and that's it. It doesn't try. It doesn't try to isolate the fault by.
There is an option in the future when in first phase, what we are going to do, we are going to handle only the simple disturbances. Once we are successful, then we will move on towards the complex situations. This is a new system, so first time we are going to implement. This is not implemented anywhere in the world, so we will still learn from the mistakes and from the feedback of the control room operators. And in the next phase, we will try to implement more complex situation in the rules.
Yeah. Okay.
Oh, sorry. Go ahead, Peter.
Yeah. So as far as I can see, DMS at the moment has a sequence of switching that isolates the faults.
Yes. So this one, it's only isolate, but there is no restoration for the faults.
That's right. So it only is off and that's it.
Yes.
But that's just like a normal circuit breaker. When it finds a fault, it's off and that's it. I mean, where's the advantage in that? I mean,
because the alarms, what you are receiving at the control center, the application will analyze the alarm, like in case of under frequency operation. So if there is no real under frequency operation, then ASGR will restore the circuit.
Right. Okay. So it all depends on the alarms it gets and what it restores.
Right.
Or isolates.
Mohammed, with you're saying that this is only going to be for 33K lines.
Yes.
So that means we're still going to have DMS for the 66K, 11K, and all that.
Right. So for initial phase, we are going to implement only on 33 kV just for the testing purpose. If it is successful, then we will implement it on another voltage levels as well.
Oh, okay. So it's like a phased implementation. So once it's completely tested and it works fine, then it'll be across all voltages, and that's when we get rid of DMS.
Right. So this application actually works based on some of the rules. So it's a matter of changing the rules only. Like, for example, I told you that right now we are implementing only very simple 3 rules in 33 kV network. Later on, we will try expand these rules. There is no boundary for these rules. We can add as many as we want.
That's right. But there's very few outages on 330 on 33 kV.
Yes, so just for the testing purpose, we will do it initially on a very small portion of the network with minimal configuration. With the passage of time, as this application will become mature, we will gain more and more experience as well as confidence on these applications. We will implement more rules.
So you're going to, you're going to have a test environment that you can run a 33 kV circuits in fault situations and test the system that way.
Right. First of all, we will implement it in the testing system. Then we will implement on the real-time system. And in the real-time system, for some period, we will just test this application.
Okay, now that's all great. It all depends on the communications between alarms, correct?
Right. This is one of the major risks. Also, it's written down in the risk management plan, because if there is any problem with the communication of the signal, the application will not work.
That's what I'm getting at, because we're having a lot of problems with
Yes.
communication at the moment.
Key risk for the project is miscalculation of protection signals and wrong decisions for supply restoration. Even if we receive the alarm, but the alarm receive with a delay, because the application has a 30 seconds to take the decisions to analyze the alarm. If the alarm comes after this window of 30 seconds, then it will not be calculated for the analysis. Then definitely application is going to take a wrong decision.
Yeah. Okay.
So this is the things we are going to implement. We are going to check during the testing that how robust the system is. The 30 seconds time for the application is kept based on the feedback from the communication departments.
The only thing I can see as a risk, a big risk, is, I mean, this is designed to pick up faults and automatically restore the power, the power supply. So when there's times like storms, this will be handy, but it'll be tripping. There may be multiple chances of multiple trips during storm activity. And one of the things about storm activity, communications tends to degrade significantly during storm activity. So that's, yeah, it's going to try and address the problem of automatically restoring the power, but during a time when there's high communication problems. So how are they going to tackle that?
Right. You are right. The success of this application mostly depend on a successful communication. But if you consider this problem will also face by the control room operator. If there is no communication, then also control room operator will not take any decision, right? He has to send someone in the field to check the alarm. So same for this application as well.
Yeah. Oh, okay.
So the main purpose for this application is to replace the control room operator or to help the control room operator during high workload. You must have a robust communication system, for which we already have another project in the same pipeline to replace the communication of the network with the radio mesh networks.
Okay. Yeah.
So I hope you don't have any questions. And even if after the presentation, if you have any more questions, you can contact me anytime. I will be available.
Okay.
Thank you so much.
Thank you.
Thanks, Mohammed.